So we touched on spheres in the last video. We're looking for, always underline volume, what you're looking for, and the shape spheres, and then write it down. The volume of a sphere is 4/3 pi or cubed. Go to the formula booklet and get it. So in A here, we're told the sphere diameter 30. So immediately write down r is equal to 15. That's the only unknown. Pi is a number. They'll tell you what to use. If they don't, you choose. So in this case, the volume is 4/3. You can write multiply if you want, but you don't need to. And they've told you to take pi is 22/7. And then by r cubed, which is 15 to be cubed. So just get good at typing these fractions into your calculators. And this is coming out at 14,142.8 something. So we'll go 143. And we're dealing in centimeters, and we're dealing in cubed. So a sphere, again, radius 12, pi is 3.14, so the volume, not 3 on top, 4 on top, 4/3 pi, which is 3.14, by the radius, which is 12 to be cubed. I'm typing this into a calculator. 4/3 by 3.14 by 12 cubed is 7234.56. So we'll go 7235. We'll round them off. 7235, and we're in meters cubed this time. Part C, we have a hemisphere, so we're looking at 2/3, and we have the radius 10, and we're given pi. So the volume of this hemisphere in part C is 2/3 by 3.14 by the radius to be cubed, which is 10 to be cubed. And that's going to give us 2093. 209, is it above? 2093.33 recurring, so 2093, and that's in millimeters cubed. We'll just round these off because they're such big numbers. Okay, question 4. The curved surface area, which we looked at being 4 pi r squared for the sphere, 3 pi r squared for the hemisphere, because we have to add in this circle here at the top. If we cut a sphere in half, as we saw before, we've got this circle on top to give us 3 pi r squared. So again, this is just formula use, really simple, straightforward in terms of pi here for the first one. And a sphere of radius 4. So a sphere of radius 4, we're asked for the curved surface area 4. I'm going to write CSA, the curved surface area is 4 pi r squared for a sphere. So for this one, where r is 4, we have 4 by pi by 4 squared, and that's 4 cubed, which is 64 pi in terms of pi. So that's the curved surface area. The hemisphere, radius 25, so the hemisphere is 3 pi r squared. So therefore we're going to get 3 by 3.14 by the radius squared, which is 25 to be squared. And we better put the units in because this now looks bigger than the first one, but the first one you can see is meters. So we have meters squared here. This is centimeters. 3 by 3.14. Which is giving me 5887.5. Actually, so we'll round it off to 5888. It's a nice round number. 5888, and we were dealing with centimeters squared. That's question 4. Now, question 5. It gives you the following picture. So we have this net here. We're given a circle on top. We're given. Now, you know, if you've watched any of my videos of my really atrocious drawing skills, and look at that line. What is that? It's not even attempted a straight line. So we have a net of a cylinder here. You can see if we take this side and turn it in this direction in a circular motion and fold these circles here, if we fold this circle down this way and this circle up this way, we'll end up with a cylinder. And the measurements on here, in here, or is equal to 5 centimeters, and we're given 30 centimeters here. So that's obviously the height of the cylinder, and nothing more than that. And you're asked And you're asked to find the volume. Now this is part C of this question 5. We'll come back and do it A and B. I'm just looking at the net first. So the volume of this cylinder is pi r squared h, which is equal to 22 over 7, which we're told to take pi as up here in part C as well. Well, actually, no, in part C we're told to take this 3.14. 3.14 multiplied by the radius 5 squared by the height, which is 30, is going to give a volume of, and that's 2355. You can ignore this question. This is actually question 6. That's 2355 centimeters cubed. I missed here, it was question 5. So let's look at question 5 over here and draw the cylinder, mixing up these questions. A cylinder with no top, so it's open, has a radius of 3.5 and a height of 8. So there's only one circle compared to this net that we were doing here, and maybe not a bad way to introduce question 5, nets of cylinders. So this is a net of any cylinder, so I would recommend draw the net and then put the measurements on. Just make that line a bit straighter. So we could say it's at the bottom. So we have a radius of 3.5, so that's in here. That's my r is equal to 3.5. My height is equal to 8 cm, and if we fold this rectangle around, say starting at this point, ending up here in a circular motion, it will wrap around the circle. Now, what length would this top be? It would be the length of the circle. Maybe we should have made the circle a bit bigger, but the length of the circle is 2 by pi by r, which is 3.5. So this one is going to be 7 pi in terms of pi. If you wanted to do it in terms of pi, we could get the area, the curved surface area in terms of pi, be 8 by 7. We're asked to find the total surface area, but take pi as 22 over 7. So if we look at the total surface area, we have 8 by 7 pi, which is 56 by pi, which is 22 over 7, and 56 and 7. There's a relationship, is 8 by 22, which is 168, and we're talking about centimeters squared. And the area of the circle is pi r squared, which is 22 over 7 by 3.5 to be squared. I'm just looking at 168, 176, 160 and 16, 176, trying to do arithmetic in my head. If I try and do this in my head, I'd say 3.5 squared, we'd have 22 over 7 by 3.5. I was already looking at this when I had the mistake of the last one, so that divides into that twice. 2 into 22 is 11. You can do all that in your head pretty quickly, and 11 3.5s is 10 of them, which is 35, plus 1 of them, which is 35, and 3, 38.5. And if I add 40 on here, I'm going to get 216, so it's going to be 214.5 cm squared. And question 5, is that it? That's all we were asked to do in question 5. That's all we were asked to do in question 5. Okay, that's the first kind of introduction to spheres. I've got a cylinder here in here as well with a net. So spheres and cylinders in this video. Watch it again and maybe try these questions yourself to master this topic.